This is Unit 5, video number 11, Stoichiometry, Simple Moles. We're going to look at stoichiometry, which will allow us to go from amounts of products to reactants, or amounts of reactants back to products, or even products of products. We could do, there's lots of different ways and different reasons in chemistry we would do them. You've got to understand this. So one of the things we want to understand here, we've got a reaction of phosphorus with fluorine producing phosphorus trifluoride, okay? These coefficients mean something to us. Obviously, the subscript of the fluorine just tells us what fluorine is. Fluorine's F2. This tells us what the relationship between fluorine and phosphorus in a compound is PF3. But these coefficients tell us the ratio of moles necessary to react. So we can think of this as two atoms of phosphorus react with 3 molecules of fluorine to produce 2 molecules of phosphorus trifluoride. That's not really the way we're going to work with things, because chemists don't really have the ability to work atom by atom. Okay, so how do we work? We work mole by mole. Or we can do half a mole or a quarter mole, things like that. But we're working mole by mole. So the way we want to think about this reaction is 2 moles of phosphorus will completely react with 3 moles of fluorine and produce 2 moles of phosphorus trifluoride. That's going to be the way we want to look at stoichiometry. Okay? So we call the relationship between 2 molecules in a reaction the mole ratio. So let's say we had 1.5 moles of phosphorus. And we want to know how many moles of PF3 would be produced. Well, we have the information here. So we can say, okay, 1.5 moles of phosphorus, and then we're going to set up our mole ratio. What we have goes to the bottom, what we want on top. So we're going to have phosphorus on the bottom, PF3 on top. Notice, this calculation assumes fluorine is there, but it does not use fluorine at all. A lot of times the problem will say in excess fluorine. That means there's plenty of it available. We don't have to worry about it. We'll talk about it later in a different video about what do we do when we don't have plenty of it available. Okay, so the ratio here is built on the moles. So there's 2 moles of PF3 for every 2 moles of phosphorus. So that means that we're going to produce 1.5 moles of PF3. Okay, so 1.5 moles of phosphorus produces 1.5 moles of PF3. Let's do one more. What if I had 1.5 moles of fluorine? Okay, now my mole ratio, fluorine's going to go to the bottom and PF3 on top. So I'm trying to find out if I had 1.5 moles of fluorine, how much PF3 would I make? So now I'm going to have 2 and 3. So I'm going to get basically 1 mole of PF3. So 1.5 moles of PF3 is going to make only 1 mole of 1.5 moles of fluorine is going to make only 1.0 moles of PF3. So the mole ratio is going to be critical. It's going to tell us how the molecules are going to react. Again, here we're assuming plenty of phosphorus available. It's not limiting the reaction in any way.